The README file contains all the relevant information on how to run the Matlab code. The dictionary.m contains the code to create the dictionary that was mentioned in the presentation slide. On running the code, we get the variable dict, which contains all the words which occur in both the training and testing dataset, along with the frequency of the number of times they occur in the training and dataset in the corresponding row. Next, we need to run the files trainProcess.m and testProcess.m, which creates the feature training set and the feature testing set for both the training and the testing set dataset respectively. Since this takes a lot of time, they have been stored in the .mat file features.mat and have been preloaded. Next, we need to run the naive base code. Here, line number 2 contains the code for creating different training datasets, that is, size ranging from 100 to 700 emails. On running this section, we get the total time for the naive base classifier is 0.1759, and as you can see, the percentage of wrongly classified documents varies from 2.6923 for 100 training samples to 2.3077 for 700 training samples. Next, we run the linear SVM code, and on running this, we can see that it takes around 1.5 seconds, and we can see that the number of documents wrongly classified ranging from 24 for 100 to 7 for 700 training samples, and you can also see the percentages decreasing from 9.23 to 2.6923 as the number of training samples is increased. Next, we run the nonlinear SVM code. This takes around 2.13 seconds, which is slightly longer than the linear SVM, and you can see the percentage wrongly classified is 50%, which is very inefficient. And finally, we run the main KNN, which contains the code for the KNN classifier, and on running this section alone, it gives us the performance of the KNN classifier, where the percentage of wrongly classified documents decreases from 21 to 7% when the training samples is increased. Now let us plot the graph. For that, we need to run the plot section. Now, as you can see from the result section in the presentation slide, the naive base has the best performance while the nonlinear SVM has the worst performance. Now let us plot the time complexity. For that, we need to run the Matlab file timeplot.m. On running this, you can see once again that the naive base has the best performance while the SVM nonlinear has the worst performance. This brings to the end of my presentation slide. I would like to thank Dr. Wu for his inputs and his lectures. Thank you. Have a good day.